The general theory of evolution says that all living things came from a single cell, and that cell came from something like a primordial soup. And for me as a chemist, the hardest problem for evolution is the origin of first life from non-living chemicals, and this is commonly called chemical evolution.
Most people have heard of the Miller-Urey experiment, and it's in most textbooks still today. They wanted to see if organic molecules could come from inorganic precursors. So they took some simple chemicals and they ran them through a spark chamber. And most of the products they got really amounted to nothing more than a brown tar, because random chemical reactions produced random molecules. And yeah, they found a few amino acids, but in a mixture of left and right-handed forms. But what they didn't find are certain specific amino acids that are critical for life. They didn't find nucleotides. They didn't find any large biomolecules.
To get living things, we need lots of huge molecules, and that means we have to get little molecules to combine into big molecules. Now, the problem is that chemicals don't react in that way. Everything I've learned in real chemistry shows that the reactions go in the opposite way from what's required for life to come from non-living chemicals. Any chemist trying to do that would not have water in the reaction, because water tends to drive the reaction in the opposite direction towards the little molecules, and yet the primordial soup would inevitably have loads of water in it. So it's the last place any real chemist would try to make proteins or DNA. Another problem with chemical evolution is called the chirality problem. Now, amino acids in proteins and sugars in DNA come in two mirror image forms, like your left hand and right hand. But all the amino acids in our body are left-handed, and all the sugars in DNA are right-handed. But a primordial soup would have an equal number of both, and it's quite complicated to get a single-handed mixture. And a primordial soup does not have that know-how, and therefore it's totally unsuitable for the origin of life.
The most common scenario for the evolutionary origin of life is called the RNA world. Here they imagine an ocean or a lake full of RNA molecules that are able to reproduce themselves and that slowly evolve into the first reproducing organism. The RNA world is a desperate attempt, a last straw, a grasping at nothing, and it is completely unscientific.
There's no RNA that can copy itself from its individual building blocks without a protein to help it do that. And so for evolutionists to claim that RNA world is possible is dishonest.
To make it even worse, RNA is more unstable than DNA. In your cells, there are about 1 million DNA breaks every day. Most of those are fixed by the unbelievably intricate and amazing repair systems in the cell. But if RNA is less stable than DNA, and DNA requires exquisite repair systems to survive over time, how on earth can an RNA world be plausible?
Also, the building blocks of RNA are threefold. You've got a sugar, a base, and phosphate. And naturally, these things don't combine to form the nucleotide bases needed for RNA. So right from the start, you've got a problem in trying to get even the building blocks of RNA. And the components of the building blocks are very unstable. Ribose and the bases decompose really quickly.
Enzymes are also needed as a catalyst in the cell, and RNA can do this to a very limited extent, which is why the evolutionist appeals to this initial RNA world idea. But the reality is that in living cells, protein-based enzymes do most of the work. So life somehow had to switch from RNA enzymes, for which there is only very limited support, to these incredible protein enzymes. How and when did that occur?
An enzyme is a molecule, it's actually a catalyst that makes a reaction go much faster without being consumed in the process. I mean, there are some very important enzymes essential for life that speed up the reaction by 10 to the power of 18 times, which means a reaction that goes in about 100th of a second in living things would take millions or billions of years to happen without the enzymes. So you need these enzymes for life to exist. If natural selection can't explain these enzymes, all evolutionists have is chance. So is the chance feasible? Well, consider even the simplest possible living thing would have to have over 350 enzymes to work. And the enzymes are made of a very precise sequence of amino acids. Now, we could be very generous to the evolutionists and assume only 10 amino acids in each enzyme have to be exact. Now, work out the probability of, say, 350 enzymes with only 10 amino acids each enzyme being exactly right. The chance there is like guessing a 5,000-digit PIN the first time. Even a 4-digit PIN on your bank card is supposed to be enough protection for you, and the bank will tell you if someone got it right, you must have left it lying around somewhere. It didn't happen by chance. So how much more a 5,000-digit PIN? It's not going to be guessed by chance. So here's the real chicken and egg problem here, because the information in the DNA requires enzymes to read it, but the instructions to build those enzymes are on the DNA, which cannot be read without enzymes. So which came first, the enzymes or the DNA?
Most cellular processes, including things like DNA replication and protein synthesis, are powered by a molecule called ATP. And the ATP synthase motor is one of the wonders of the universe. It's a tiny electric motor required by all life. This rotary motor uses protons to generate spin and then uses that to join ADP molecules to phosphate molecules, creating ATP, or adenosine triphosphate. All life is based on ATP. It's called the energy currency of the cell, and your body produces its own weight of ATP every day. And that motor works at nearly 100% efficiency. ATP is a complex and reactive molecule not found in abiotic systems. Yet without ATP, life could not exist. How did life decide to use that molecule for energy, and where did it get it before it could produce it?
It's not sufficient to invoke scenarios where I could imagine biochemicals arising spontaneously. Life isn't based upon biochemicals. You can have all the biochemicals you want, and it's not going to give you life. You can have all the amino acids you want. You can have all the proteins you want. You can add RNA to the soup. You can add DNA to the soup. You can even add membranes to the soup. But number one, they will never assemble into a coherent, correctly assembled cell. And even if they could, you still wouldn't be anywhere near creating life because you have not introduced into those molecules information.
Now think about information in the form of books, which is ink molecules written on paper. The information didn't come from the ink molecules. You could pour ink on a page and you would not get a book out of it, because the information in the books is the result of a mind organizing those ink molecules into letters and words, sentences and paragraphs. For instance, the simplest living cell, the mycoplasma, has about 600 kilobytes of information.
It's like an alphabet. The letters do not say anything at all. It has to be in the right position, and it has to be interpreted. And that is what is going on in the cells of living beings.
You see, there's nothing in chemistry alone that would put any sort of coded information into a molecule. I mean, even if you could get nucleotides to form in a chemical soup, and even if you could get them to form a chain, you'd have nothing but a random string of letters. If you were to wait for a very long time and by chance produce a coherent string with a real instruction, even then, it would be just one clear message in a sea of random messages. This is the opposite of what life requires. Life requires lots of information, tightly controlled and protected, able to be copied, able to be fixed when an error appears. And all of this must be present the first time life appears.
When the DNA was first decoded, and scientists started looking at the simplest living cell, they imagined that possibly we could have a cell with a couple of hundred proteins. Well, it's up to over 400 now. And even the origin of one of these proteins by some chance process, it's not going to happen even on a universal time scale. And even if every atom in the universe was an experiment for every possible molecular vibration of its supposed billions of years of time, you would never get one protein, let alone hundreds, let alone the DNA to actually code for them. I mean, the idea of the origin of life by natural processes is a preposterous idea, absolutely preposterous idea.
Many evolutionists claim that the origin of life is not part of evolution, but come on, they believe that all living things came from a single cell, which in turn came from a primordial soup. So they have to have a theory of life coming from non-living chemicals, otherwise materialism is dead in the water. For evolutionists to believe in chemical evolution, this is not a position they got from science, but a position they got from blind faith. They're basically having to believe in miracles because it's not real chemistry that they can appeal to.
Evolutionists often accuse creationists of believing in a God of the gaps, where they say that we claim God just did it that way when we run into some process that we don't quite understand. But very often when faced with an unanswerable question, a problem like the origin of life, evolutionists invoke their own Darwin of the gaps. See, everything we know about the laws of chemistry, about genetics and statistics and information theory argues against any life from non-life idea. But an evolutionist must believe that scientific laws are violated for life to arise from non-living chemicals. That sounds like faith to me.
I think one of the biggest challenges for evolution is the origin of the first life. Life supposedly coming forth from a chemical soup. Scientists have had decades to reproduce this in a laboratory, but they haven't been able to do that, despite all the time they've had, despite all the great equipment. And I think that's tremendous evidence that life can't evolve from a chemical soup.
Many evolutionists admit that life from non-living chemicals is a huge problem for life on Earth. So they've resorted to the idea that maybe life came from outside the Earth, and this is called panspermia. Now, there are two versions of this one. One is undirected, which just says that chemical evolution happened somewhere and life was naturally seeded onto Earth somehow. Now, this doesn't actually solve the problem of life from non-living chemicals. It just puts it into the unknown. In fact, it puts it beyond science. So you might say it's a Darwin of the gaps theory, not science at all. Another idea is called directed panspermia, where you have intelligent aliens seeding life from outer space onto Earth.
Francis Crick, the primary discoverer of DNA, is one of those scientists who realized it can't happen spontaneously. So he, like other scientists, are imagining that intelligent life from outer space brought life to Earth, and they find that more credible than the idea of spontaneous origin of life.
Evolutionists who resort to directed panspermia are in fact tacitly conceding that life was intelligently designed. The only difference is their designer is an alien, not the God of the Bible. Of course, this is most convenient for them because the God of the Bible has certain moral requirements, while aliens don't. So they can have all the benefits of a designer without the moral obligations to him.
Studying the origin of life is totally ridiculous in the light of our modern understanding of the most simple living cells and what it needs. I was in a meeting recently where an origin of life scientist was telling about his studies, and a professor next to me whispered to my ear, "What on earth does this have to do with science?"
This whole study of origins has more to do with history than science. We're told the fossil record is supposed to be a record of evolutionary history on Earth. But notably absent from any rock anywhere is any trace of a primordial soup. If chemical evolution occurred over millions of years, and if rocks form slowly and fossils accumulate slowly, there should be a record of this somewhere in the fossil record.